Okay, hello all. Welcome to another video uh, of the series Data Science with Julia. So today we are going to see about a thing called naive Bayes. Okay, so let's see what it is. Like actually, like yeah, I learned about this from this blog. I think I'll also give its link. And I simplified this blog even more. And what to say, like I'm just presenting it, and that's what would even go into my book. So hopefully, yeah, no copyrights or something, or no suing or happens. But yeah, like this is a very simple example. So that is like I've simplified. Hopefully, it will make sense to you, right? So like it follows a thing called Bayesian theorem. So I don't want to AYSE, yeah, Bayesian theorem. Okay, so uh, oops, my spelling is really bad. So this is it. But the thing is like, yeah, I don't want to explain this and confuse you. But possibly in my book, I'll be putting this theorem and explaining it more and all those stuff, right? So, but it has got a lot of uses and it has got a lot of uses in data science. And apart from data science also, it's got a lot of uses. So this is the thing. But I'll be telling only the essence of it, like how we are using it to solve statistics. Sorry, solve like text classification, right? So that's the thing. So imagine like okay, we are given a sample text. Of course, this is all like okay, like supervised learning. That means you'll have some thing and that will be labeled or something like that. Okay. So here you have some text. Okay, a great game and it's having a label called sport. The election was over, it is having label called politics and so on and so forth. So in reality you'll be having like thousands of things. Imagine okay, these things are tweets, that is this text column is tweets or something like that, and this label columns are nothing but what to say, uh, a classification of the tweets or something like that. Okay, so something like that. Okay, so that's the thing. Okay, so now let us calculate the probability of election in this what to say label politics. Okay, so totally how many words this politics has? So politics has like 1, 2, 3, 4, 5, 6, 7, 8, 9 words it has, and there are two election in politics. Okay, so that's the thing. So it's 2 by 9. Okay. Similarly, like this thing, sport has 11 words, and we have like game in sports. Okay, so there are two games in this tag sport. Okay, so and totally sport has 11 words. So if you count and see, you will know. So yeah, this link I'll just give this link to my book. Okay, I'll just give. Now I'm just running it in my local host, but yeah, I'll just give the link. Okay, so that in this video you can understand. Okay. So surprisingly, if you seems to have this kind of data, like you can predict something like a very close game. You can predict whether it's sport or politics. So we'll see how it's done. Okay, so how it's been done is like we will compare whether okay probability of very close game to sports. So how we will do is like okay, now we know like how to calculate this word probability in this label. Okay, or this word probability in this label. Okay, so it seems to be very simple. So what we need to do is okay, for a very close game, whether is it, what is the probability of this being a sport label or not? Look, very close game is not at all over here, right? So how we'll calculate this probability is we'll just calculate for each and every word what is the probability it's in sport. Okay, so that's how we'll just calculate, and we'll just multiply all and we'll just get it. But over here there is no word called close in this sport. So if you look over here and over here, there is no word called close. Okay, so then it will become 0, like so it will be 0 by 11, so the entire probability will be 0. And similarly there is no word called close in even politics, I think. Oh, there is one thing. Okay, there is one thing. Okay, but the thing is okay, if you try to calculate with sport, it'll be 0. So how to mitigate this problem? So there is a thing called additive smoothing. Okay, so you have this numerator denominator. Okay, so the numerator is something 0 here, so in this case, and the denominator is 11. Okay, so and you'll just have some constant, let us keep it as 1 or something like that. So that's the thing. And okay, like Okay. The denominator is not actually 11. The denominator is actually like number of possible words. So okay, you take all these words. Okay, so okay, let me just show it to you in Jupyter lab. Okay, so the thing is, yeah, I think I need to close this one. Okay, no need. Okay, okay, I'll just show it in Jupyter lab. Okay, so this is the thing. Okay, so I have a data frame over here, right? So there is a data frame, and I've just put all text over here and all labels over here. So this is the exact data frame what we get over here. So let me just put it nearby so that I can show it to you. Right, okay. So this is the very same data frame over here, right? So now I just want to do, okay, I just want to take all text, okay? So all text, this should be df of, okay? And we are getting all, what to say, rows, and the column name is like what? Like, I think it's called text, okay? So text, okay? So if I just do this, I'll just get this. But no, like we need to get like something like uh, into like, okay, this is like a 5 element vector, but we need to make this a string. So what I just do is I just use this join function. I just join it with space. Okay, so that's what I just do. So now I am just getting all text as this. Okay, so if I put length, okay, look, okay, if I just take words is equal to split of all text. Okay, so and if I just put like that, I just get 20 words. Okay, but if I put like this one, like set of words, that is, I just need only the unique words. Okay, so I'm just getting 15 over here, right? So yeah, 15, I'm just getting it over here. So okay, so I'm just getting 15, right? So now what I just need to do is like let me just close this window. Okay. So yeah, so I'm just getting 15 over here, right? So what I just this dr will be actually 15. Like this is the all possible words in the data frame. Okay, so that's the thing. Okay, and it is also called as n. Okay, so there is a Wikipedia article called Additive Smoothing, and in this Additive Smoothing, we are having it as n over here. So I'll also put this link so that like you will know, right? So that's the thing, right? I'm just giving a very simplified thing so that you will understand. Okay, so that's the thing. So okay. So okay, like okay, then why I'm putting n is equal to 14 over here? Should be 15, right? Oops. Okay. I just get it. Okay. So, okay. What I just did is like I need to put lowercase. Okay. So, okay. So I just need to put lowercase because the capital and small are the same, right? In reality. Okay. So set of words means it'll be 14. Okay. Fine. Right. I just thought, yeah, I just made a very fatal mistake. Okay. Right. So n is 14 over here. Right. So that's the thing. So now if you just put this one like 0 by 11 is equal to this one and all those stuff, and okay, over here, okay, d is the dimension is nothing but the number of words in the sports. Okay, so that's the thing over here. So okay, I need to change this thing. Okay, so d is the dimension. Okay, so but yeah, this is just a draft chapter I'm just writing in the book. Okay, so but yeah, so please bear. So when this book is when this section is ready, yeah, this should be explaining it really well. Okay, so that's the thing. So the dimension is number of words in sport. That is like this is non-unique. Okay, so like if you totally measure sports, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. we are not uh, saying like, okay, okay, so 1 2 3, right? 4 5 6 7 8 9 10 11. We are not saying that this game and this game are same, so we must make it as one word. So this is non-unique thing in this port, or whatever label you are just looking. These are the entire word set, unique number of word set, and alpha we are just keeping it as one. You can keep it as any constant, it doesn't matter, but for simplicity's sake I'm just keeping it as one. When I substitute in this equation, okay, so what it comes to 0.04. So like we are mitigating this zero thing over here. So if you calculate all this, you will just get a number. Similarly, calculate it for even politics, okay, a very close game in politics, okay, and whichever is higher, you will say it belongs to sport or politics. Like if P of very close game of sport is higher, then you will say it as sport, or if P of very close game of politics is higher, you say it as politics. Now we'll see it in action. Okay, so that's the thing, right? So okay, so we have done something over here, right? So, okay, let me tell you the code. Okay, now coming to practicality. Okay, so look, you can do everything by your hand or something like that, but you need to code it into programs, right? So, what is data science? Mathematics plus or data with computer science. Okay, so computer science is used to execute the mathematics. Okay, so you have a data frame, okay, the very same data frame over here. Okay, now I'm just doing this MLlib. So I'll tell you why we are using it. Now I'm just writing this additive smoothing function over here, right? So this is the additive smoothing over here. So you're having this numerator, denominator, and then n, I'm just keeping this 0 by default, and alpha is equal to 1. Well, the thing is, yeah, I'm just doing this very same equation over here. So this very same equation, I'm doing it over here, right? Okay, so I'm just calling it as additive smoothing. Okay, so that's the thing. So yeah, this is the thing that finally describes, okay, uh, probability of words. That is, words means, okay, like, okay, all these words, like whatever it is, of label, whatever label, sports, politics, or whatever it might be in your case. So you just take, this means I think product of, so that's what I just put. So for each word you just do additive smoothing of p of word label. So okay, this means product of, just like summation of, you'll do additive smoothing of p of every word, then multiply it, multiply it, and so on and so forth. So that's the thing. Okay, so in theory, okay, yeah, this is what written in very generic format is this one. Okay, so that's the thing. Okay, so that's the thing. Over here the words is very close game, and the label is sport. Okay, so that's the thing. Okay, so yeah, we have got it. And okay, so this is the additive smoothing function I just wrote. This is just a test, I'm just doing it. Okay, so just ignore it. Okay, so, and now we are just coming to this word probability function. Okay, so this is one word probability, that is p of, let's say, a in sport. Okay, so that's the thing. Okay, so what we are just doing is we are taking the word, now we are setting it as defaults. Okay, if alpha is nothing, we are setting it as default as 0. I wanted it to be 1. Okay, but yeah, let it be 0 now. Okay, right? And then we are, okay, we want to know what is the default text column in the past data frame. Okay, we are passing data frame over here. Okay, so we are taking the word over here, let's say and over here the classification sport or something like that, and we just want to know what is the probability. Okay, and we are taking this data frame over here. This data frame is nothing but this very data frame. Okay, so we just want to know what is the probability. Okay, so these are all we are getting, and if there is no text column given in config, it takes the text column as text. So here we have it as text over here, and if there is no label column, it takes as label. So we have label over here, right? So that's how it works. Okay, right? Now it gets all text over here. This is all the text over here, right? Okay, so it just takes all text over here. So just we have done it over here, right? And then what we are just doing is we are just splitting words okay, and now we are just taking length of set words, okay. So that's what we are just doing. Actually, in alt text we are just doing the lowercase over here. So this should be 14 in our case now, okay. So now we are doing a filter, okay, whatever is the label column. So if you are putting sport, it will form a sport filter over there. Yeah. So if you're not knowing what it is, please go to the previous videos in this playlist, look into data frames and how filters are being created and all those things. And now this data frame filtered, okay, so it's nothing but we are just taking this df and we are just filtering it. And I just made a very big blunder over here. Okay, I should put local df as this data frame, okay, but I haven't done it. Okay, otherwise it's going to become an error and it's going to take from this global one. Okay, so that's the thing. Okay, so anyway, like I just made a very big mistake. Okay, I just need to. Okay, it's a very huge mistake. Okay, right. Okay, so that's the thing. And df filtered we are just getting. Okay, and now we are just getting the filtered text of only this df filter. Okay, so we are just getting this text over here, right? And okay, and we are just lowercasing it, joining with the space and all those things. And now this word count, okay, now this total word count, not the unique word count, we are just taking the total word count, we are just taking. And now we might look for the word counts of, okay, like let's say like p of in sport, okay, it'll be there like p of in sport is, okay, there is in sport, okay, I think it is there. No, sport doesn't have in it, a very clean match. Okay, it's not even a very clean match. Okay, there is okay. Very is there close. Okay. Okay, so for all these things, we'll get a count. Okay, I think you need to go and look into this MLlib. I think I also need to give the link, or in this code repo you will find it. Okay, so okay, so in this word counts, we are just putting it as counter and split of this one. So you need to go to this MLlib and look into this counter to see what it is doing. So what it will do is, like when you get an array, if there are four, what to say, okay, if this port has game twice, it will just give an dictionary like saying like, okay, like game is two counts, and then that is a is one count, and so on and so forth. So that kind of dictionary it just gives. Okay, so yeah, that's what it'll do. So and next what you're just doing is, like, you are getting the word count. If there is no word in that word count, okay, so what you're just doing is, let us this word, okay, you're getting it as 0. Okay, and then finally you're applying this additive smoothing, so that, like, even if 0 is there, like, it will take care. Okay, so that's the thing, right? So yeah, that's what you're just doing. And finally you're just finding the probability of this thing, game and smooth. It is coming to 0.12. Okay, now the string probability is nothing but, okay, I hope you understood this one. Okay, so that's the thing. The string probability is nothing but, like, you're taking each and every word over here. Okay, and first you are having this probability 1, and next you're just taking the word probability and you're just multiplying it with this probability. And now, so the first time this probability will become word probability of whatever it is, and that's the thing. Second time it will just get multiplied, and it will follow this rule, like for each and every word it'll get multiplied. Okay, so this is what is happening in this function over here, string probability. Okay, string probability uses this function word probability. Okay, so that's what this is. And okay, so now we can find the string probability of this string. Okay, now we have this string, a very close game. So we are having string in we are just finding this probability of very close game in sport, and we are getting it like 4.6 whatever it is, e power minus 5. And next we are just doing it in politics, it's still e power minus 5, so we can ignore, we are getting only 1.4. So 4.6 is greater than 1.4, so we are putting it, so we can conclude this as port. Okay, so this is the thing what I've automated it. Okay, so I am just put like label text I've just put. Okay, so we are getting the text and data frame out here, and we are getting the config over here. So oops, so okay, so what I'm just doing is like, okay, like once again I'm just setting the default things, and I'm just assigning df is equal to data frame. Okay, what I'm just putting max probability 0, so I think like probability can't go below 0, and first time label I'm keeping it as nothing. And next I'm just taking all this classification column, so the unique values in this classification column. So what will be the unique value this time? It will be sport and politics. Okay, so I am using the set function to take it. Okay, so for each and every classification, I'm calculating the string probability of this text, whatever text we are passing. Okay, so that's the thing, and whatever the classification is there. The first time it might be sport, next time it might be politics. Okay, and now when uh, probability greater than max probability. Okay. So when this probability is greater than max probability, so when in the first time it will be greater, so the max probability will become probability this time. So the first time, let's say it's 4. Okay, so it will be 4.6, whatever this number. Let's forget this e minus 5. Okay, so 4.6 it will be, and so it will be 4.6, and so the first time the label is sport, so the label will be sport. And now it will just come for the second time, that is the label will be politics. Okay, so now it will be only 1.4, so the probability is not greater than max probability. So it will just come out, and next, so the label will still be sport, and it will be thrown out. Okay, so now we can just give a label like, okay, string. What the string is nothing but a very close game, right? Now we are just giving this thing. Okay, like I'm just calling this function label text a very close game. Now I'm just giving the data frame and this alpha value. I'm getting it as sport. Okay, and next string also we are having, I'm a politician who won election. Okay, so we are just giving this string and this data frame, and we're just giving this config over here, and it's going to be politics. Okay, so ultimately, like when I am committing this code, I need to do two things. First, alpha needs to be 1 over here, and over here this df needs to be data frame. Okay, so I've done this blunder, so but yeah, I'll correct it and I'll push the code, and after that only I'll upload and link all those things in this video description. So anyway, like I hope you people have understood it. So hopefully the code is not complex. Okay, even though if it's complex, yeah, please go through and understand. And this is how name base is being used. And I'll also in the coming days I'll update this my book section, and I will upload it and all those things. And if you go to this thing, data science book dot gitlab.io. Okay, my internet went away once again. Oh my god, I'm just having internet problems a lot today. Okay, so if you, okay, like, okay, let's say like I'll just do it in local, so that okay, so if you go to this book and what to say, like you can see get updates link. It will take you to a Telegram group where I'll be, whenever I've updated the book, I'll put it over there, so you can become member over there and all those things. So my internet, I don't know, it's screwing me up today like anything. Okay, so yeah, I'm sorry about that. Okay, so yeah, anyway, thanks for watching the video. I hope you enjoyed it. Oh, okay, if not enjoyed it, okay, understood it and all those things. Anyway, I hope you like, subscribe to this channel if it's good. Anyway, thanks for watching. Bye.